Good evening, students, again. Welcome to today's mathematics class. This is a long break we have done. Last class was on Monday and today is Friday. So, no problems. Before today's class, I just want you to revise some things. That is, before attending today's lecture, you should be revising the principal value range. Because as we have said last time, the PVR, principal value range, is the most important part and it's a very conceptual thing, this chapter. So we have to know the PVR. So now, before diving into the questions, let us revise the principal value range and their quadrants. So we have seen these quadrants for sine inverse, cosec inverse, and tan inverse. I hope you remember these three: sine inverse, cosec inverse, and tan inverse. Their principal value range PVR are in which quadrants? First quadrant and fourth quadrant. And again, for cos inverse, for sec inverse, and for cot inverse, the PVR are from first quadrant and second quadrant. Now, note that if we, for example, take sine inverse, sine inverse value can be positive or negative. And as we all know, sine inverse is positive in first quadrant and negative in third quadrant. Along with this, we also did the angles. Like if the first quadrant angle is alpha, the corresponding angle in the second quadrant is pi minus alpha, and the corresponding angle in the fourth quadrant is minus alpha, because in the fourth quadrant we go clockwise direction. So these two important things we need to remember. Now, let's jump into the questions and you will see how easy the questions become once we know these two things. So yeah, before diving into the questions, let's rub all this. Okay. Now, let's see. So, the question says, find the principal values of the following. Now, what is meant by principal values? The meaning is very simple. Principal values means I have to give answers from the PVR. Let us take the first question, which is sine inverse of half. Let me do this question and you just see how I approach the question. And the rest of the question you can do very easily. So as I have seen, we have to do two things. First is decide the quadrant by positive and negative, and then decide the angle. Now, as we can see, this value, half, is a positive value, and PVR of sine is in first quadrant and fourth quadrant. So if it is a positive value, then what will be my quadrant? My quadrant will be obviously first quadrant because of this. You know, no? ASTC. So now I have to think what value of angle in the first quadrant will sine give a half of. It's very simple. That is 30 degrees or pi by 6 radians. So simple. This is the answer. Now let's go towards second. First question is done. Let's go to the second question. Second question says that cosec inverse of 2. Cosec inverse of 2. Again, we need to decide two things. Cosec inverse of value, cosec inverse of positive value. Now, positive value we know, cosec inverse ka PVR is first and fourth quadrant again. So, out of which, if the value is positive, we look into the first quadrant. Now, it's very simple. What value of theta will give cosec theta as 2? So my answer should be obviously again 30 degrees, which is pi by 6 radian. I hope you remember the tables, the trigonometric tables for values: sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degree. Same for cos, tan, cot, cosec, and sec. So that will be very helpful here. Now, let us jump into the third question. Third question is somewhat interesting because tan inverse of -1. As we know, tan inverse also has a PVR in first quadrant and fourth quadrant. So if my value is negative, tell me which quadrant should I look for? First quadrant or fourth quadrant? And I hope you guessed it right because it should be fourth quadrant. As we have negative value, it will be fourth quadrant. Now again, this table we have to remember, if the angle in first quadrant is alpha, the corresponding angle in fourth quadrant is minus alpha. So we have, so for negative values, it's very simple. Just get the angle in the first quadrant and accordingly we'll get an angle in the fourth quadrant by just adding a negative sign. So as we can see, for first quadrant, what will be the value of theta, which will give tan? Answer 1. I am not saying, be careful, I am not saying -1, I am saying 1 because I am looking in the first quadrant. So as I know, 1 in the first quadrant for 10 gives 45 degree, which is pi by 4. Now, my answer lies in the fourth quadrant. Don't forget negative part. This is very simple mistakes we make, but please just make sure you don't make these mistakes. Now, my answer is in fourth quadrant. I got the first quadrant answer. That means I got alpha as pi by 4. So what will be my corresponding fourth quadrant answer? It will be minus alpha. So it will be just minus pi by 4. I hope you are getting it. Also, I don't want to spoil your future, like the future of inverse trigonometry function. But once we do properties, mainly property number 2, then it will be very simple for you to tackle these negative ones, negative values. These negative values will be tackled very easily, but just so our basics and concepts are clear, I am going through these questions. Third question is also done. Let's come to fourth question. Fourth question also says tan inverse of minus root 3. Now again, I have to give principal value. See, just pay attention to how I approach the question. Principal value tan inverse ka PVR is in first and fourth quadrant. Here it's negative value. So my answer is in fourth quadrant, means my answer is minus alpha. But to get minus alpha, you need to understand we need alpha. So for alpha, we need to jump into first quadrant, means we need to ignore negative. So ignoring negative, tan inverse of root 3. Now, I hope you know tan inverse of root 3, what angle will it be? I guess you are correct because it is pi by 3 radian or 60 degrees. Again, don't make the mistake, this is 60 degrees in the first quadrant. So what will be in the fourth quadrant? Simple, minus 60 degree. Fourth question done. Let's look at the fifth question. Fifth question says sine inverse of 1 by root 2. So 1 by root 2 is a positive value and sine inverse PVR is first and fourth quadrant. So which quadrant are we looking at? First quadrant, because 1 by root 2 is positive. The answer in first one very simple. What angle of sine will give 1 by root 2? And that will be 45 degrees, which is pi by 4. And the last part, be careful because we have cos inverse of minus half. This cos inverse is careful because cos inverse PVR is in first and second quadrant. Now, let us think this through. If cos inverse PVR is first and second quadrant and the value is negative, which quadrant will it be? First quadrant or second quadrant? It will be second quadrant because cos is negative in second quadrant. Now, if the angle in the first quadrant is alpha, what is the corresponding angle in the second quadrant? It is pi minus alpha. So, to get the corresponding angle in second quadrant, again, we need first quadrant angle alpha. And for first quadrant angle alpha, we ignore the negative sign. So, cos inverse of half. Which angle gives cos inverse of half? It is 60 degree, which is pi by 3 radians. But remember, I want cos inverse of minus half. So what is cos inverse of minus half? Second quadrant, which is pi minus alpha. Alpha for quadrant angle is pi by 3. So my answer will be pi minus pi by 3, which by LCM will get as 2 pi by 3. This is my answer. So yeah, these questions are done. I hope you understood this. You will like it will be more simpler for you if when we know the properties. If we know the properties, then these negative will be easy to tackle. Now let's look at some other questions for practice. Evaluate. Now this is we have to find all the sum. As we can see, all the values 1, half, and half are positive. Means for positive values, we only need to look in the first quadrant. So this is very simple. I hope you'll all get it. Tan inverse of 1. What value of theta in the first quadrant gives answer 1 for tan? You are right. Pi by 4. Same for cos inverse of half. What value of cos theta will give half? Now, half gives, half gives, half gives. We have done this in the previous slide. 60 degrees, which is pi by 3 plus. What value of theta in the first quadrant gives sine of half? Again, it is 30 degrees, which is pi by 6. We just have to add this. I hope you are familiar with LCM. So what will the LCM 4, 3, and 6? It will be 12. So here we will get multiply and divided by 3. So 3 pi multiply and divided by 2. So 2 pi, 4. Sorry, multiply and divided by 4. So 4 pi and multiply and divided by 2. So plus 2 pi. Now, what is the final answer? 4, 5, 6, 7, 8, 9. 9 pi by 12. We can reduce it by dividing with 3. So, we will get 3 pi by 4 is my correct answer. I hope you are getting this. Now, this is enough practice for PVR. If you want to do more practice, I'll send you the sums of where you can do the more practice. But now let's see here. Let us revise what we have done till now. The main thing we have done is the PVR and questions based on PVR. Now, I hope to do at least let me tell you what we are going to do next. Now we are going to do the last part and the very important part of inverse trigonometry, on which mainly questions are asked in JEE, which are the properties of inverse trigonometric function. Now, I have personally divided the properties into 6 sets. Like there are 6 different formulas. 6 set of formulas. There are not only 6 but 6 set of formulas. So I hope to cover at least 3 sets for today. So if we cover 3 sets for today and look at the examples on how we should apply those properties, I think we are good to go. And next lecture will complete the chapter. So let me take you to the next part, which is the interesting part, which are properties. Now, properties are basically like formulae. So I hope you are good with memorizing. You have to memorize these formulas. Then it will be very easy for us to solve the questions. So let us jump into the next part, which is properties, where we are going to do properties for set 1. Set 1. Let us go properties of inverse trigonometric function set 1. Now, let me tell you one thing. You will kind of relate all these properties on some level with trigonometric properties. Now, let me show you what properties will we do for this set 1. What we can relate from trigonometric properties. So, sine and cosec are reciprocal of each other. Similarly, cos and sec are reciprocal of each other. Similarly, tan and cot are reciprocal of each other. So we have 3 pairs. So that reciprocal property is similarly applied in inverse trigonometric function. Here also, as you can see, for this property, we have sine inverse, cosec sine, reciprocals of each other. Then cos inverse, sec inverse, cos inverse, reciprocal. tan inverse, cot inverse, tan inverse. Again, reciprocal. So I hope you are familiar with these things. So the property is simple. Sine inverse of some value is equals to cosec inverse of reciprocal of that value. Please listen to my words very carefully of what I am saying and try to understand it. Don't just memorize the formula, it's very logical. Sine inverse of a value is equal to cosec inverse of reciprocal of that value. And same vice versa. Cosec inverse of some value is sine inverse of reciprocal of that value. Now let me clear very one thing. Since we are talking of reciprocal, we'll only get three pairs: sine inverse, cosec inverse, one pair. Second is sec inverse, cos inverse, and tan inverse, cot inverse. So same is for cos and sec. Cos inverse of some value is equal to sec inverse of reciprocal of that value. Similarly, sec inverse of some value is equal to cos inverse of reciprocal of that value. Now let me tell you a very interesting thing on where these properties will use set 1. Set 1 is mainly used to convert the trigonometric ratios of sec inverse, cosec inverse, and cot inverse into our most lovable trigonometric ratios, which are sine inverse, cos inverse, and tan inverse. I don't know about you all, but I guess I would be right because I know that I am familiar, yeah, I am easy with sine, cos, and tan. I don't like to deal with cosec, sec, and cot. So this property helps us to convert cosec, sec, and cot into sine, cos, and tan. Now see, let's take an example of what we have done previously. Do you remember this example? Cosec inverse of 2. Find the value of cosec inverse of 2. So let us, for example, say I am not comfortable with cosec inverse of 2. So by this property, I can write cosec inverse of 2 as cosec inverse of a value is equal to sine inverse of reciprocal of that value. Cosec inverse of some value is equals to sine inverse of reciprocal of that value. So cosec inverse of 2 will be simply sine inverse of 1 by 2. Now I hope you are familiar, you are comfortable with sine inverse value because I am too comfortable with this value. I don't like dealing with cosec, sec, and cot. So this property mainly helps to convert cosec, sec, and cot into more comfortable trigonometric ratios, which are sine, cos, and tan. So now this question becomes very simple. Sine inverse of half. Again, positive value means we'll look into first quadrant. Now, first quadrant will look into what value of theta will of sine will give half, and it is 30 degrees, which is pi by 6 radians. So I hope this property is clear to you. Now, let's go into set 2. Set 2, mark my words, is very important property. There are many questions in JEE mains which will solve like this if we know how to use set 2. Many students get confused here, so I hope you'll pay attention. I am hoping you'll pay a little bit more attention here. You are paying attention from start. Thank you for that. So now let me explain what this property says. Please listen very carefully. Don't just memorize the properties. Listen how they are used. So you'll be familiar. You don't have to memorize. It's all conceptual. This property says that if somewhere I get sine inverse of sine theta, then I can write that as theta. Basically, I look at I can cut sine inverse and sine, and all I'll be left with is theta. But I can cut this or I can use this only if my theta is in PVR. Theta is in PVR. And for sine inverse, the PVR is minus pi by 2 to pi by 2. The PVR is minus pi by 2 to pi by 2, which is first and fourth quadrant. And same is valid for all the other trigonometric ratios. Cos inverse of cos theta is theta. If theta belongs to PVR, cos inverse PVR is 0 to pi, which is first and second quadrant. Tan inverse of tan, cosec inverse of cosec, sec inverse, cot inverse. Now, after I let me point out, after doing set 1, I hope we do not have to go through these, because we very well know how to convert cosec inverse, sec inverse, and cot inverse into sine inverse, cos inverse, and tan inverse by set 1. So I hope you are very familiar in this. Let me again go through this. If theta is not in PVR, there is written here in highlighted format, what if theta is not in PVR? If theta is not in PVR, we'll use allied angles to reduce the angle into PVR. Now, again, here comes the important part, which is allied angles from your trigonometry. So, allied angles, let me tell you, I hope you remember allied angles. Allied angles, again, I hope you remember. Yes, no. I think you all remember allied angles. If not, I would like to see you all revising allied angles and then attending the next class, because allied angles are very, very, very helpful here. So let us look at how to apply these properties in questions. Or do you want me to revise allied angles? Okay. Let's just see some examples on allied angles. If I write sine pi minus theta, if you remember the how we used to find the principal solutions, this slide, how we used to do two steps: decide the quadrant and decide the angle. Similar way have to do here. Pi minus theta. An angle is getting subtracted from pi. Now, if you know pi is 180 degree, which comes here. If an angle is getting subtracted from pi, the angle will come into second quadrant. And as we all know, in the second quadrant, sine theta is positive. So my answer will be positive. And here, it is pi. It is pi. Pi is an angle on x. Means sine will remain sine theta. Suppose I get sine pi by 2 minus theta. Listen to me very carefully. Angle pi by 2 is here. And if I subtract theta, I will reach in the first quadrant. So again, first quadrant ASTC, sine is positive. So my answer will be positive. But look at here. Pay very important attention here. Here it was pi, which was angle on x-axis. Here it is pi by 2, which is angle on y-axis. So if we get angle on y-axis, we change the trigonometric ratio. That is, from sine, it will be changed to cosine, which is cos theta. So only two things we need to remember. See the quadrant, first quadrant, second quadrant, third quadrant, or fourth quadrant. And lastly, second is see whether here the angle, that is pi or pi by 2, is whether on x-axis or y-axis. If it is x-axis, sine will remain sine. If it is y-axis, sine will convert to cos and vice versa. And same is for tan and cot, cosec and sec. Tan and cot, one pair, cosec and sec, second. So I hope you are now ready with allied angles. So let us go into next set of questions based on this property. Find the principal values. Again, the question is based on principal values. Means I need to give an answer in the PVR. Now, let's take the first question. First question is sine inverse of sine 2 pi by 3. Please note, I cannot simply write it as 2 pi by 3 because the angle given here should be in PVR. It is not in PVR. So what have we done if the angle is not in PVR? If the angle is not in PVR, we need to bring that angle into PVR. How we bring the angle into PVR? We bring the angle into PVR by using allied angles. Now, let me see what I can do here. Sine of 2 pi by 3. I can write sine of 2 pi by 3 as sine of pi minus pi by 3. Here comes the allied angle part. This will be equal to sine inverse of sine pi minus pi by 3. Now look at the allied angles part. This is angle pi. Some angle is getting subtracted from pi. So that leaves me in the second quadrant. That leaves me in the second quadrant. Second quadrant sign is positive. So my answer will be sine inverse of positive. And here, don't forget this angle pi is on x. So that will mean it will not change. So it will be sine pi by 3. Now check if this pi by 3 is in PVR. Pi by 3 means 60 degrees and 60 degrees is in the PVR of sine inverse, which is minus 92 plus 90. So we can simply give this answer as pi by 3 radians. So sine inverse of sine 2 pi by 3 is equals to pi by 3. I hope you are getting it. Let us try one more example, which is second one. For second question, it is cos inverse of cos 7 pi by 6. It is a very interesting example. Cos inverse of cos 7 pi by 6. Now, does 7 pi by 6 belong in the PVR of cos inverse? Let me remind you, PVR of cos inverse is from 0 to pi, 0 to 180 degree. So if we look at 7 pi by 6, I don't think it comes between 0 to pi. It doesn't come between 0 to pi. So what we'll do here, we'll bring into PVR by using allied angles. By using allied angles. Now, let us write this as cos inverse of cos 2 pi minus phi pi by 6. Please check. 2 pi minus 5 pi by 6 after taking LCM, 12 minus 5, 7 pi by 6. It will come as 7 pi by 6. Right? I hope you are getting it. So, now again 2 pi angle comes here. An angle is getting subtracted from 2 pi. So, where that leaves me? That leaves me in the fourth quadrant. And in fourth quadrant, cos is positive. So we'll get cos inverse of positive. Now, check 2 pi. 2 pi is an angle on x or y? It's on x. So if angle on x, there will be no change. Cos will remain cos. And this will be cos 5 pi by 6. Now, check if 5 pi by 6 is between 0 to 180. Let me give you a hint. 5 pi by 6 means in degrees, it means 150 degrees. So 150 degree lies in the PVR of course, which is 0 to 180 degree. So I can use set 2 of the property and cut this cos inverse and cos, and I can write the answer as 5 pi by 6. So this is my answer. So cos inverse of cos 7 pi by 6 is 5 pi by 6. Chalo. Now let me give you a chance to try the third one. So I'll rub this. While I'm rubbing, I hope you are getting a chance to solve the third one. If you come up with an answer, then please let me know. It is tan inverse of tan 3 pi by 4. 3 pi by 4, let me tell you, 3 pi by 4 means 135 degrees. So it is not in the PVR of tan inverse, which is minus 90 to 90. So we have to use allied angles. How will you use allied angles? I hope you know how to use allied angles. We have done in previous 2 questions. Come on, 30 more seconds. 30 more seconds. Then I'll start. Okay, let's start. Now let me tell you one important thing here, which we have been missing. That is 3 pi by 4 is a standard angle. We directly know the value of tan 3 pi by 4. Would you like to try? It will be tan inverse of tan. If I use allied angle, I can write this as pi minus pi by 4. Now pi minus pi by 4, something is getting subtracted from pi. So we'll land into second quadrant. Second quadrant mein tan is negative. So I will get tan inverse of minus this pi. Pi means on x-axis mean there will be no change. So we will write tan ka tan pi by 4. Again, now this is what I was telling. I simply know the value of 10 pi by 4. 10 pi by 4 means 1045, which is minus 1. And now we are back into the principal solutions. Tan inverse of minus 1. We have done it here. See, tan inverse of minus 1. Now I will hide this slide and let you answer. I have to give principal value means my answer should be in first and fourth quadrant. This value is negative. Now this value is negative, meaning my answer will be in fourth quadrant. But I need first quadrant alpha, alpha minus alpha. So for first quadrant, we ignore the negative. So what value of tan theta will give me 1? That is pi by 4. And if it is in fourth quadrant, the corresponding angle will be minus pi by 4. So my answer to tan inverse of tan 3 pi by 4 is minus pi by 4. So I hope you got it. Now, let me just revise the set of properties we have done till now. We have done two sets, set 1 and set 2. Set 1, I like to call it reciprocal one. Reciprocal one means we use that to convert sec inverse, cosec inverse, and cot inverse into our more comfortable, more loving, which are sine inverse, cos inverse, and tan inverse. Now, set 2 is a very important property, as you have seen. We'll use this in sums coming afterwards, which are very important, which are past year JEE questions. So I hope you remember. Just I before attending next class, if someone is not familiar with allied angles, just go through or revise allied angles from trigonometric function. Now, as in starting, I have told you I hope to cover at least till set 3. So now we have begun set 3. Set 3 is just, you can say, ulta, like somewhat ulta. Set 2 mein we had sine inverse of sine theta. So here it is just ulta. Sine bar aa gaya. Sine has gone outside. Sine inverse came inside. Sine of sine inverse of x. The theme is same. We need to look at x. Since x is a value, please understand this. Here, theta was an angle. And for inverse, angle comes in range, PVR. Here, x is a value. And value for inverse comes in domain. So here I would like to point out x should be in domain of sine inverse. Now it is very simple. We have studied like so many times this. Sine inverse ka domain is from -1 to 1. Same is for cos. Tan and cot are all real numbers. Sec and cosec are less than -1 and greater than 1. So this is like we hardly use or we somewhat use this. Not that important. So just I want to mention if this comes, again, x should be in the domain, which is very simple. -1 to 1, -1 to 1 for sine cos, tan cot mein all real, sec cosec mein everything except from -1 to 1. Everything except from -1 to 1. Okay, so suppose, let's take for example, there are not many questions based on this, but for understanding, let's take it sine of sine inverse of half. Now just check if this half is between -1 to 1. Obviously, half is between -1 to 1. So if half is between -1 to 1, it looks like sine inverse get cancelled and my answer will be simply half. So this is the basic use. Now, after set 3, I would like to go into trigonometry again. And a very important thing we'll learn from trigonometry, that is converting one trigonometric function into another. Please note. Actually, you are very familiar with this. I like to call it as triangle method. Triangle banao, answer pao. We just have to make a right angle triangle and we'll get all our answers. So that's what I remember this method as, triangle banao, answer pao, which we use to convert one trigonometric function into another. So let me take an example. I guess we have all done this, but again, if I write sine theta equals to 3 upon 5, where theta is in first quadrant, find tan theta and cos theta. So the way I approach this is, if sine theta is 3 upon 5, now we all know how sine theta came by original definition. If this angle is theta, Sine is basically opposite upon hypotenuse. So opposite is 3, hypotenuse is 5. Now I hope you are familiar with Pythagorean triplets. Pythagorean triplets here, Pythagorean triplet 3 and 5 is with 4. So adjacent side will be 4. Now since theta is in first quadrant, please remember theta is in first quadrant, meaning all my trigonometric ratios will be positive. Whether it will be sine, cos, tan, cosec, sec, all of them will be positive. So if someone asks me to find cos theta, I can easily say cos theta is adjacent upon hypotenuse. And look at this triangle. If this is theta, adjacent is 4, hypotenuse is 5. So simply my value of cos theta is 4 by 5. Again, it's a positive value because theta is in first quadrant. And if someone asks for tan theta, low by tan theta is opposite upon adjacent. What is opposite? 3. Adjacent is 4. So 3 by 4. So please remember, this is a very useful tool in my inverse trigonometric function. Now, how to use it, I'll show you in the next questions. Triangle banao answer pao is one of my favorite methods because it solves many questions, like many questions. So let us take a question based on this method along with based on set 2. Let me give you the next question, which is this. Chal. If I take the first question, it is cos of sine inverse of 3 by 5. Basically, this is based on property third. See, imagine, let's make a cloud. If I were to get here, instead of sine inverse, I got cos inverse. Just imagine. If here instead of sine inverse, I got cos inverse. Suppose I get cos inverse of something. Then if this belongs from -1 to 1, please note this should be between -1 to 1. Then I can easily cut this cos and write the answer here by set 3. Remember set 3. This part. Cos of cos inverse x equal to x if -1 to 1. So let me tell you this way. Basically, I need to convert this sine inverse into cos inverse. So this brings me converting one trigonometric function into another. Converting sine inverse into cos inverse means converting one trigonometric function into another. And for this we use triangle banao, answer pao. So let us go through with it. So my aim is now, okay, how to solve this question. So I'll write let sine inverse of 3 upon 5 equals to theta. As we all know, sine inverse का input is value, output is angle. Sine inverse का output I rotate the angle. Now implies by inverse properties, like from definition of inverse, I can write sine theta equals to 3 by 5. And again, I hope you remember we just did this question here. Sine theta is 3 by 5. So that's why I took this question then. But let's solve it again. If sine theta is 3 by 5, let's make triangle. Triangle banao. Theta, sine is opposite upon hypotenuse by Pythagorean triplet. This will be 4. So I need, remember, sine inverse, cos inverse. So I need cos theta. So cos theta will be adjacent upon hypotenuse. So from here I can write theta as, by definition of inverse, cos inverse of 4 upon 5. Now see these two. That means if sine inverse of 3 by 5 is theta, And theta is equal to sine inverse of 4 by 5, meaning theta को equate कर दो, equate both. So sine inverse of 3 by 5 can be written as cos inverse of 4 by 5. After some time, we'll skip this part. There is no need of this part if we know the Pythagorean triplets. So we can directly write sine inverse of 3 by 5 once we become some fast. Sine inverse of 3 by 5 is cos inverse of 4 by 5. So now let's come again here. So I can write this as I am successful in converting cos inverse of 4 by 5. Just I need to be careful of one thing. This value should be between -1 and 1. And I hope you can see it is between -1 and 1. So basically I can cut this and my answer would be 4 by 5. This is my answer. So my answer is basically 4 by 5. I hope you got this. Let's take some 30 seconds and again I will not talk and just you go through this sum, how we approach the sum, because next sum, second one, I'll give you to try. 30 seconds, everyone, please mute yourself and just go through the question, how we approach the question. I hope you are done. Chalo. Now, before starting the next question, we don't have space. So, let me erase all this. Yeah. Let's start. Let's approach the second question. So, second question says tan of sine inverse x. Now, assume that instead of sine inverse, I had tan inverse. If this belongs to real numbers, means anything it could be possible, then I can directly write it as this. So basically, I need to convert sine inverse into tan inverse, which brings us, I need to convert one trigonometric ratio into another. क्या use करेंगे? What will you use? Triangle बनाओ, answer पाओ. Now let's check this. So let's again step one. Let sine inverse of x equals to theta. Sorry for my bad handwriting. I am very bad. I have a very bad handwriting. Please adjust. So if sine inverse of x equal to theta, then by definition of inverse, I can write sine theta equals to x. Now I can write x upon 1. क्या फर्क पड़ता है? Who cares? X upon 1 is simply as x. But here I can directly get triangle बनाओ, answer पाओ. This is theta, sine is opposite hypotenuse. After using Pythagoras, I will get this as under root of 1 minus x square. Now remember, I need sine to tan. So I have sine theta. I need tan theta. Tan theta is opposite upon adjacent. So opposite, which is x. Adjacent, which is under root of 1 minus x square. So by again definition of inverse functions, I can write theta equals to tan inverse of x upon under root of 1 minus x square. Now again look at these two. If sine inverse x equal to theta and theta equals to tan inverse of x, means I can write equating both sine inverse of x equals to tan inverse of x upon under root of 1 minus x square. So after simply using this, here my task is completed for converting sine inverse to tan inverse. So I can write this question as, please see, equals to tan inverse of x upon under root of 1 minus x squared. Now, simply please note that this belongs to R, like this is a real number, right? X upon under root of 1 minus x square, whatever may be the value of x, this will always be a real number. Meaning I can use set 3 and I can like simply cut this and my answer will be x upon under root of 1 minus x square. This is my answer. So again, I need to point it out, if we know Pythagoras, like Pythagorean triplets, we are very familiar, we can directly skip all this and directly write this box. So my tan of sine inverse of x is basically equal to x upon under root of 1 minus x square. Sorry for the writing. Yeah. So again, I will give you 30 seconds. Please go through this. This is very important part. 30 seconds of complete silence. Just concentrate on the screen, on the work. So I hope you are done in this. Now, I just want you to remember here. Let's recap what we have done. Again, first thing we did was PVR, which is very, very, very important. Let me stop this so you can see me clearly. First thing we did was PVR. PVR, you have to remember, and we did 3 set of properties, set 1, set 2, set 3. In the next class, we'll be completing inverse trigonometric function by doing set 4, set 5, and set 6 properties. And we'll look at some questions. Out of set 1, set 2, set 3, my most important property is set 2. Please remember, set 2 is the most important property on which most of the questions from JEE mains are asked. I just would like to remind you again, if you are not familiar, if you have some doubt in allied angles, please go through your notes and all those things before coming in the next lecture, because it is very helpful. If you know allied angles, it is very helpful for me. Although I've tried to revise allied angles here, I've given some 5 minutes to revise. We have seen some examples. But again, if you are still in doubt, I hope you get to revise it again up. You will revise and come in the next class. So for today, we are completed. We have done some very amazing things today. Thank you for all your support. You are very good students. I would like to again mention next class will be completing the chapter with set 4, set 5, and set 6. And if you have any doubts, please bring in the next class. We'll do complete the doubts and then proceed further. So I hope you are done here, and bye bye. Thank you all. Thank you. Bye bye.